All right, welcome back. Still talking about global climate change. I know, you guys are getting bored of me, I'm sure, but this is good, important information. We talked about heat spells, we talked about increased heat waves, right? Now we're looking at cold spells, which could have some positive impacts and effects and expand the range of pest species. Not as positive. So what's happening in the Midwest? We're starting to see these polar vortexes. And so what normally happens is there's a strong jet stream of air currents traveling from west to east, right? Our normal wind current. And the strong polar wind spins at the top of the pole, which allows that cold air to come down, but not too far because the strong jet stream stops it from getting too deep. When we get a polar vortex weakening, the cold air is able to travel farther. The jet stream is no longer a straight, flat path. It travels up, gathers that cold air, and brings it down into the east. So when we hear polar vortex, we're hearing usually places in the Midwest experiencing very, very, very cold temperatures. We're actually seeing it right now, literally right now, but you're not watching this video until after spring break because right now is probably April for you. But right now in February, there's a polar vortex going on. And this is becoming more and more common. So we're going to have cold spells. It's going to be very cold. There's also going to be different precipitation patterns. When there's less precipitation, crops are going to need more irrigation. Where there's more, you're going to have flooding, landslides, and erosion. So you can see here, negative percent change versus positive based on the seasons, all because of higher emissions. We're going to have Waterworld. If you haven't watched the movie Waterworld, it's an old movie, and it's not very good. We're also going to see an increase in storm intensity. Ocean warming causes more hurricanes, of course, more problems. So this graph shows you the number of Atlantic storms each year, and we have moderate duration storms, which are adjusted for missing records. The short duration storms are down here, these guys. We're starting to see more severe storms. These are surges. Come on. Right? Oh no. Global temperatures are going to continue to rise. And this is a graph that shows you Katrinas per decade, right? Remember, Hurricane Katrina was very devastating. Global temperatures are going to continue to increase based on data that we have. And the number of Katrinas per decade, at one point in early 1900s, it was like, hey, you're going to have a Katrina-style event once a century, 0.1 per decade. By 2000, we're looking at 1 per decade. By 2050, we're looking at 5. So every other year, roughly, we're going to have hurricanes that are just incredibly intense. We're also seeing changes in ocean currents. So fresh water diluting the ocean, which stops the salt water from sinking near Greenland, which is going to ultimately change the current because the normal current is good, new current is not. So how the currents work normally, water moves north and then gradually cools. It mixes with cold Arctic water and sinks down. It travels, goes to an area where there's more sun. Sun heats the water in the tropics, then it moves north, right? So we see this warm air, cool, cold, bringing the cold air, warms back up. Warm water then travels back, cools back down, etc., etc. Changing ocean currents is not going to be good. Now, some of the effects on humans, of course, because that's all we care about are humans, right? Well, increased ocean levels are going to cause a relocation in climate refugees. We're going to see a huge refugee problem in the next coming decades. It's going to cause health problems and heat waves. It's going to increase the amount of infectious diseases. It's also going to hurt tourist areas. Places that rely on tourists to come for snow or coral reefs are going to find less snow and less active coral, less tourists. So how might it have some positive effects? There's got to be some positive. There's got to be. Well, there's going to be fewer deaths and crop damage due to cold weather. Cold weather usually causes more deaths and crop damage. So there's a positive. There's going to be new habitats that will be hospitable to humans. Areas further north will now be places where we could live because they're warmer. And depending on the areas, there will be higher amount of rainfall, which can recharge the aquifers and allow for more crops. So there are some positives there. We got to be positive sometimes. So in 1997, Kyoto Protocol was put in place to set goals for global emissions of greenhouse gases to be reduced by 2012. Different amounts were required from different countries. Like the U.S. was 7% reduction. Developing had no limits. And the U.S. refused to ratify this. Because to ratify this for the U.S., and this is where, we kind of enter the political realm of things, because you have to be able to get a 2/3 majority of the Congress to ratify these types of agreements. And the U.S. refused, saying that they wanted developing countries to have more limits on them. 192 countries were involved. These are the countries that signed and ratified. Canada ratified and then withdrew. And we signed it, but we never ratified it. The goal was to get a drop of 5.2% greenhouse gases by 2012 relative to 1990. The gases that they were targeting were methane, carbon dioxide, and nitrous oxide. They were also looking at hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride. Now, the precautionary principle is a really important thing we've talked about before in this course. The idea here for what we're talking about is if we can reduce emissions, we can increase fuel efficiency and use renewable energy, right? Carbon sequestration is where we return agricultural lands to pasture and forest. We capture CO2 from emissions and pump underground or into the water. So the precautionary principle says, hey, we're going to get out when you can prove that it's not a problem, that it is a problem. When we get out, we will get out when you prove to me we will be boiled alive, versus we should get out until you can prove we won't be boiled alive. So the idea of the precautionary principle is let's solve the problem regardless of our agreement on it, because it's better to be safe than sorry. And then this is just an interesting graphic on the Bay Area, San Francisco area, fairly close to us. Some of the direct climate change effects to the Bay Area, for instance, high energy waves created by El Nino storms in 2012 and 2016 prompted unprecedented beach erosion. Moisture levels in California declined to the lowest point in more than 1,000 years because of the drought. Coastal fog in the Bay Area has become much less frequent than it once was. In the last 100 years, the sea level in the Bay Area has actually risen 8 inches. Since 1950, the average annual maximum temperature in the Bay Area has increased by 1.7 degrees Fahrenheit. And over the past 80 years, the Bay Area land burned. In the past 80 years, the Bay Area land burned during large fire, quote unquote, large fire years, has continued to increase. There have been more and more wildfires in the area. So that's going to be the end of our very incredibly long section on global climate change, but it is an incredibly important topic that we need to understand.